Check, 1, 2, 1, 2, 1, 2. Oh. Yeah, okay. Good. Good morning, everyone. Welcome to the Beginners TDD workshop. My name is Harry. I will be your instructor for today. Thank you very much for coming. Thank you to each and every one of you that has done the preparation and installed the required software before we started. That really saves a lot of time, so thank you on behalf of everyone in the room. Thank you. I really appreciate that. I have often done tutorials where we've spent 25 minutes before really getting started, so we're already off to a great start. My name is Harry. Thank you also for agreeing to doing a bit of pair programming. So as long as you're sitting next to someone, you've decided to do some pair programming, just make sure you've also picked whose laptop are you going to use. Now, don't worry if yours is not the primary laptop. If you get through this a little bit quicker than everybody else, you can always jump onto your own laptop, have a little hack. And when we finish today's tutorial, everything I'm teaching is based on a book that I wrote called Test-Driven Development with Python. And the whole tutorial exactly tracks the first 4 or 5 chapters in that book. So if you're worried that, oh, I didn't get to do it on my laptop, don't worry. You can go home tonight, run through those chapters. It will be much quicker, and it will reinforce your learning. So please, please do choose one laptop. Choose a text editor that you both agree on. Don't inflict Vim or what's it called? Emacs on someone that doesn't know it. And now symbolically close the other laptop, at least for a moment, just to prove your... There you go. All right, close the second laptops, everyone. I want to see one laptop per 2 people. Properly close it. Come on. It'll switch on again. I promise. How are we doing over here? There you go. There's 2 laptops. No, come on, symbolically close one laptop. I want to see it. Are you guys pairing? Very good. Come on. There we go. All right. All right. I'm not seeing symbolically closed laptops over there. You can reopen it later. Come on. Come on. All the way down. Just close it. There we go. Close it properly. I see you. All right. Come on. Slip, slip, slip. Right. Great. Fantastic. All right, so the plan today is to do a little bit of an introduction to test-driven development, and we're going to be using the example of a web application, so we're going to use the Django web application framework. I wrote this book initially as an introduction to Django and testing, but I quite like the fact that it uses a real web framework because that introduces complexities. And a lot of introductions to TDD will go, oh, let's make a Roman numeral calculator or some, completely abstract example, which is nice, but it doesn't get you into some of those complexities of real-world software development. So by building a web app, we're actually going to learn some things about integrating different layers of the software stack from the very beginning and using databases and web browsers and things like that. But it's a concept that you can apply outside the realm of web development because every domain has its kind of layers of integration and different stacks in the architecture. And so you can take these concepts anywhere. So yes, Django web application. My name is Harry. I've said that. We're doing pair programming. That's great. Ma'am, take a seat, see if you can find yourself next to a group of 2 or 3 people. And we're almost ready to go. As we go through the class, I'm going to demonstrate things, then I'm going to leave it over to you. I'm going to say, blah, 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 this is what we're doing, demo, demo, demo. Do you understand? And I'm going to say, hey, do you guys get that? Are you okay with it? Now, please don't do this if what inside your head is going on is... All right, because we always do this. We think, oh, okay, I'm not sure I understand right now, but if I just hold on a bit, maybe it will become clearer later. It won't become clearer later, and you will just get more and more lost. So ask that question immediately. Don't be embarrassed. First of all, you might be scared that you're going to look like an idiot because you're asking an obvious question. There are no obvious questions. There are no dumb questions. I will be giving out prizes for questions today, stupid questions. And secondly, I guarantee you that whatever question you think you have in your mind, there's probably about 3 people in the room who have the same question, and they will be so glad when you ask it. Now, don't rely, therefore, on somebody else asking it. Go ahead and ask that question as soon as it occurs, and I'll answer it, and we'll make sure we're all on the same page. We're going to go through this at the speed of the slowest group, so I'm going to make sure that you all get through it, and all get through the examples. And to try and keep that going, I'm going to suggest a couple of advanced exercises as we go for people who get through it quicker. There you go. You're in your pairs. We've talked about me and how we're going through the workshop, and that's us almost ready to go. Any questions before we start? There's a prize, remember, for any kind of question. Yes, yes, yes. What are the prizes? Well, I used to give out discount coupons for my book. I don't know if I mentioned I wrote a book about testing, test-driven development. It's free online. You can get it, www.obeythetestinggo.com. But now those don't apply anymore, so I'll have to think of something else. But I'm sure there will be prizes. Yeah. Good question, sir. You could get a prize, notionally. Any more questions before we start? Yes? What does TDD stand for? TDD stands for test-driven development. And so we'll go on and talk about that now, I suppose. So I learnt Python from a book called, what's it called? Dive into Python. Did anybody else read that? Yeah, a couple of people. So for the people who remember it, do you remember in Dive into Python, around chapter 14, there's a chapter on testing, and it uses like a Roman numerals calculator as an example. Does that ring a bell? Okay. So I read this. I was just learning Python, and I read this, and it showed you how, if you wrote a series of tests, even before you wrote a function, it could help you get that function right first go. And it said, okay, let's make a Roman numeral converter, and it should convert I to 1, and II to 2, and IV to 4, and IX to 9, and things like that. And you could write all these tests before writing the implementation, and then you could write the implementation. It gave you this freedom to get your code right first go and to refactor it. And I thought, wow, that sounds great, this testing idea. It sounds like something you should really should do, you know, like flossing your teeth. But then I got my first real client and my first real project, and there were deadlines, and you know, all of my good intentions about testing went straight out the window. And besides, from the full height of my 3 weeks of experience with Python and Django, I thought I was probably good enough and I could get away with it and I'd be fine. And do you know what? I was fine at first. So I built a little like Django app, and it was fine, and I had a couple of pages, and I would click through them, and I would make changes, and I'd go back and look, and it was fine. And then kind of the weeks passed, and the months passed, and it grew more pages, and I'd read good principles, like don't repeat yourself. So I thought, oh yeah, DRY, and I started having like inheritance hierarchies and diamond inheritance hierarchies, and going, okay, well this method over here is slightly different, but it inherits from that one, but I could just override the implementation here. Oh gosh, no, that's going to break the dependent classes, and my code got more complicated, and checking things was no longer a matter of just looking at one page and seeing if it was okay, but there were several different pages and several different things you had to do on each page to check it all worked. And I became increasingly scared of changing my code because I knew if I changed this thing over here, I didn't know what was going to break. And I kind of let my application develop a sort of uglier and uglier code base, and I was scared of refactoring. And kind of complexity eventually came around to bite me. I don't know if anybody else has had an experience a bit like that. So then I got my first sort of real employee job at a company called Resolver Systems, it was, then later became Python Anywhere. And they were an XP shop, Extreme Programming, which was this agile methodology that was invented in the 90s by people who said, let's take all of the things we love, we wish we could do in programming, but managers tell us we have no time for, and just say, well, we'll definitely do those, and forget all the stuff that we get told we have to do, but we don't really want to do, like documentation and you know, requirements gathering. And so they developed this idea of the agile cycle, of pair programming, and of test-driven development, of saying instead of having tests as an afterthought, let's write them first, and let's say we always have a test before we start. So this company introduced me to it, and I was ready for that lesson because I'd got into trouble from not having tests. And nonetheless, I kind of dragged my heels and complained about every single thing. Went, oh, what? 2 types of tests? Functional tests as well as unit tests? Aren't we doing the same test twice? Oh, really? And they would like go, let's go through small steps to write our code. And like, really? Tiny little steps? Come on, we could skip to the end. We can do this. I'm like, no, come on, Harry, this is how we do it. And so I complained about it, but over the time, I grew to see the wisdom of every single bit. And that's why I kind of had this enthusiasm of a recent convert, which I'm trying to share with you today. So good, that's the TDD origin story, according to Harry. Any questions at this stage? No. Shall we get programming a bit? Okay. So what we're going to do today is we're going to build a Django application. It's going to be a to-do lists app, because I have no imagination, and that's the example that everybody uses. But it's not a bad example because it's a really simple thing. It requires a kind of database and a data structure. It's a nice, simple web application you can build. And so we're going to build this web application using Django. So I've got I'm going to make a folder for here. Intro. We're going to build a simple Django app over here. And so for the people who've used Django before, if I want to start a Django application, what is the first thing that I should do? Anyone? Django people, what's the first thing that we do if we want to start a new project? We're doing TDD. Yes, ma'am. Import Django. That's not bad. Any other answers? Yeah. Create a virtual environment. Not a bad answer either. Yeah, you, sir? Anybody else? Okay, the first thing we're going to do is we're going to write a test, right? Remember, test-driven development. The very first thing we're going to do before we do anything else is we're going to write our very first test. So I'm going to start a file here called functionaltest.py. And in it, I'm going to go from Selenium import WebDriver. No, don't follow along now. Try and just sort of watch and listen. And then in a minute, I'm just going to hand over, and you can do the same thing and make sure it works on your own laptop. I'm going to go browser equals webdriver.firefox. So I'm doing a web project. So the first thing I'm going to do is I'm going to open up a real web browser. Selenium is a tool that lets you automate a web browser from code, from Python in this case. I'm going to tell it to browser.get http://. Now, if I'm going to do a bit of web development on my local machine, we're usually able to start up a web server on our own machine. That's called the local host. I happen to know that they tend to start on this port 8000. And I'm going to say, let's go and have a look at my own machine. If I can get started on a Django project, if I've got Django installed and running, the very first thing I should be able to do is bring up the sort of Django test server. And I can check that it's running by making an assertion. So we can use the Python assert keyword, and I can say assert Django in browser.title. All right, that could be our very first test. Look at that, just 4 lines. The first one loads up this Selenium tool. The second one pops up, opens up Firefox. The third line says, go and visit my own computer on port 8000, load up a web page there. And the final line says, look at this web page, and in it, it should say something about Django if I have Django installed. So that is the kind of simplest, first ever test we're going to write. It's intended to say, have I got Django up and running? What do you think will happen if I run this test, everyone? Let's have a look. All right, fantastic. So I'm going to get this sort of horrible, ugly traceback. Oh, no. WebDriver exception, error page, ugly, ugly, ugly. In the meantime, I'm going to get some Django thing over here with a little robot. And there's a Selenium thing over here with a little robot and Firefox. And oh, no, it's a disaster. Oh, no, the opposite is true. Hooray. This is our very first failing test. And so this is the TDD cycle. You write a test, you see it fail, and then you're going to make it pass. And the way I'd make it pass is I would, assuming you don't need to do this, pip install Django into my virtual env, and then I'm going to go Django admin.py start project. Yep. Start project. Tell you what, let's just do that much, and it'll be the very first step. Why don't you make this 4-line test, run it, see it fail, saying there is no such web page at localhost, and get to that stage. Yep. 1, 2, 3, 4. So this is your first test of can you get an editor open, decide who's going to write first. Each exercise, I want you to swap who's programming, get that up and running, and get the expected failure. All right, Jason and Mark, this is a good time. All right, everyone, look up. I'm just going to do the second part of this now. So we've seen our first expected failure. Everyone's there or thereabouts. Sorry? Yeah, thank you. And check. Everyone look up. All right, we've seen our first expected failure. Now let's make the test pass. To make this test pass, I want to have Django installed on my computer, which you have already all done because you're wonderful people and you've done the installation instructions. So I'm going to start a new Django project. So Django people, how do I start a new Django project? What does that sound? Sorry, shout it out. You get a prize. Yes, you get a prize. Okay, so I'm going to run this Django admin command, start project, and I've got to give it a name. I'm going to call it super lists because my to-do list site is going to be super. So what that's going to do, actually I wanted to try Django start project. So let's do start project superlist dot. So I'm going to do it like this. Start project, superlists, and then I put this final dot at the end, which means start the project in the folder that I'm currently in. If you don't do that, it creates a new folder called superlists, and you get one folder inside another, and it gets confusing. So Django admin, start project, superlists dot. There we go. And that is going to create a... Okay, so that is going to create for me... Let's see if you can see this. In my folder, it's going to create a new file called manage.py, which is Django's Swiss Army knife. It's going to put a new subfolder called superlists. There shouldn't be two folders called superlists. There should be just one, so ask if you get that stuck. Settings.py, things like that. But the most important thing for us to see is this manage.py, and then I can then run that Python manage.py. It's like a Swiss Army knife for doing Django stuff. And one of the things it can do is run a test server. So I can do manage.py run server over here. It's going to go and load Django. You can ignore this message about migrations. And then I'm going to need a second window. Okay. Activate my virtual env. And I'm going to go Python functional tests again. So in one window, I've got Python manage.py run server running. In the other window, I can rerun Python functional test.py. And this time, instead of getting a traceback, I just get nothing. But you'll also notice that the little window that it pops up, the Firefox window, says it worked. So that's good news. It says it worked. I've got Django up and running. And also, my test has worked. So I've been through these 4 lines in my... let's close this guy. I've been through these 4 lines. I've loaded Selenium, I've loaded Firefox, I've visited localhost, and I found Django is actually running. So I've gone from writing a test to seeing it fail to doing some sort of programming. In this case, it's just installation and configuration, and seeing it pass. And that is our first completed test-driven development loop. Write a test, see it fail, make it pass. And that's sometimes called red, green, and then we'll talk about refactor later in the data. So red is the test fails, and green is making it pass. And that's what I'd like you to get to now. Install Django, run that Django admin.py start project superlists dot, get the manage.py and the superlist folder in there, do Python manage.py run server in one terminal, rerun the functional tests in another terminal. Don't forget to activate your virtual env in both of them, and you should see the test is now passing, and it no longer has the traceback. Who's got there already? Congratulations. If you fancy an advanced exercise just to waste a little bit of time, see if you can get your functional tests running with Chrome instead of Firefox. So you can change it to webdriver.chrome instead of webdriver.firefox, and you need a tool called Chrome Driver that matches Gecko Driver, and that will give you in future the ability to run your tests with Chrome as well as Firefox. Carry on. right. Okay, have you got this? Is it working? Yes, have you got this? Is it working? Not quite.
Well, so I mined Selenium import WebDriver.
From Selenium import WebDriver?
Trying to figure out which computer we got.
Oh, show me the error.
All right. So, well, no. Yeah. No.
Yeah.
I'm not.
Okay, but it works on this one.
Don't know yet.
Let's have a look. Yeah. All right, try running that. Bitone. Are you in the right folder? Let's have a look. What was that message? Anyway, yep, good, that's the expected failure. And then over here, you can run the, what's in this folder at the moment?
Python admin, right?
LS, have a look. Manage.py, have you got, look, what are the contents of this folder at the moment? So try Python manage.py, run server. Great. All right, that works fine. Now we need a second terminal window, and it needs to have the virtual env activated as well.
Python
Functional tests. Okay. But that looks great. All right, so you've got Django 2 installed here, which is fine for now, but I think it would be better if we installed Django 1. Have you got internet okay? So here, type in pip install, and then open quotes. Yeah, Django less than. Yeah.
like that?
Yeah. And you'll be good to go. Great. You guys ready over here? Okay, so, and it passes now, and it opens the window. You're great. Are you guys okay over here?
Yep, all good.
You okay over here? Yes, great. This is Django 2. So will you run for me pip install, Alt F4 will close this window. So that looks right.
Install what?
So open quotes.
Open what?
Open quotes, like quotes. Django less than 2. Yeah. Yeah. Close quotes. All right, let that run, and you'll be okay.
Oh.
All right, how's it going over here? Yep. Is it working? Yep. How you doing over here? Good. Okay, here. Okay, here. Okay, here. Okay, here. Okay, over here. Okay, here. Okay, here. Okay, over here. Yep. Okay, good. All right, we are good to restart again. Well done, everyone. We've got our first failing test, and we've moved on to our first passing test. But it's not really ideal, is it? First of all, whenever we run it and it fails, we get this ugly trace back. Second of all, whenever we run it, it opens up Firefox and leaves that window sort of lying around. And finally, the next thing we really want to do is say that our website shouldn't be about Django. It should be about to-do lists. So supposing I wanted to change this test and say, okay, let's make sure that we've opened up a page that's about kind of to-do lists. If I change this assertion to say, assert to-do in browser.title, which is the next step I want to go to, is say, not just Django being installed, but I want to start having some code that looks like a to-do list website. If I run this test now and see it fail, I'm just going to get a really unhelpful error message that says assertion error. And what I'd really like to have is some sort of saying, all right, the browser title didn't say to do, but here is what it did say. And that gives me some better information for debugging. Now, to do that, I can roll my own. I could go, first of all, I'm going to put a try over here, and I'm going to go except, and I'm going to go browser.quit, or in fact, finally. So I can do my own cleanup, and often in tests, we set up some stuff at the beginning, and we want to clean it up at the end. So I can wrap my code in a try finally, and then there's a sort of second argument to the assert. So browser title was browser.title or something like that. So I could print my own kind of debugging messages. But that gets pretty tedious. And you know what? These problems of having helpful error messages when assertions fail and having kind of cleanup in tests are problems that everyone comes across in testing. And so there are frameworks that help you do this. Python has a built-in testing framework that's part of the standard library. It's called unittest. Now, I could go off on a digression here about unit tests versus functional tests, but whatever. We're going to use it as a testing framework irrespective of what kind of tests we're writing. And we can use the unit test library to give us these things, which is helpers for debugging assertion failures, so like useful error messages, and also cleanup code. And I'm going to show you how we would transform this sort of 4-line simple, don't type this, you guys, 4-line simple stuff into using unit test. So I would do that by typing import unit test at the top. Then unit test structures its tests into classes. So this can be like class, I'm going to test the home page, so this is home page test. We inherit from unittest.testCase. And then test methods live inside any kind of function that starts with test, T-E-S-T. So I'm going to say test home page over here. Okay, and I'm going to go and in there, this import can go at the top as well. These guys can go over here. All right. Then unit test gives you 2 special methods you can use for setting stuff up before your actual test and cleaning them up after the end, and they are called set up, like this. It's got a sort of camel casing thing. I'm going to change browser into self.browser, and tear down is what cleans it up. Tear down, self. And there is where I can use my browser.quit. That's going to go in here. It's going to become a self.browser. Thank you very much. Where is he? Yeah, okay. So, and then finally, I'm going to change the assertion into, instead of just being the assert keyword, unit test gives you some assertion helper methods. And this one I'm going to use is self.assertIn. I'm going to say the string to do should be inside the browser.title, self.browser.title. And that is going to give me the error message for free. Finally, to actually run this test, I'm going to use an if dunder name equals dunder main. Who knows what this little incantation is all about? Yeah, can you explain it, sir? Yep, that's right. So Python files, whenever you run a Python file, it runs all the code in it. Whenever you import one Python file from another, it also runs all the code in it. So this little if dunder name equals dunder main is only true if Python is running this actual file as its first file rather than as a third-party file that it's importing. And so what this is saying is, if I run this file directly, I should go in here and unittest.main will say, find all of the tests in this file and then run them. Let's see if it actually works. Python functional test.py, and so you'll notice 2 things. Number 1 is that Firefox window that popped up is automatically cleared up, which is nice. And number 2, I now get a nice kind of structured traceback error message, and it tells me to do was not found in the string welcome to Django, which is a much more helpful error message. So that is the second thing I would like you all to do, which is convert your 4-line functional test with an assert into a unit test test case, which has a class, it has a setup, it has a teardown, and it has a test method. Before we do that, are there any questions? All right, remember, don't do this if actually it's like, ooh, yes? Yes. 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 So the question there is, there are other test frameworks. A popular one in the Python world is called PyTest. Do they all have setup and teardown? Yes. All test frameworks, because these are such common problems, they will tend to have some sort of way of setting stuff up and cleaning up at the end, and they will also have some sort of way of giving you better error messages for when the test is failing. And yeah, very good question. Okay, so I'll just show you this so you can copy it. Carry on. Yes. Just checking with the last few people. If you've already finished and you fancy an advanced exercise, go to the Python unit test documentation, look up a thing called add cleanup, and see if you can use add cleanup instead of teardown. That's your advanced exercise. Who's not finished? Anybody have any problems? Hands up if you're not finished. All right. So well done for getting that done. So we've now moved from having a sort of hacky test that we wrote ourselves to having one which has the unit test framework. And so I'd like to move on to the next stage, which is sort of fleshing out our test with the kinds of things that we want to do for our real application. So far we've been hacking about saying, is Django installed, or is there vaguely a to-do list website? Now let's start fleshing out this test. And this test, even though it uses a library called unit test, is what I call a functional test. And a functional test, there's some terminology nerdery to be had here. But a functional test, some people might say end-to-end test, or high-level test, or acceptance test. But for one reason or another, it's a test that tries to look at your application from the outside, like it's maybe like it's a black box. And that's the reason it's opening up a real web browser, and it's navigating to a page just like the user would, and it's really going to test our application from the point of view of the user. So the kind of test that I'm going to write here is, what should the user be able to do on my website? And it's going to have a narrative a little bit like this. Let's see. So we're going to have in our functional test, and functional tests you might map if you're doing, depending on how your project management works, you might have user stories. Has anyone here used user stories as a way of capturing requirements? Okay. So a user story is a kind of a shortened kind of requirements documentation that really describes a little story about what a user could do on your website. And you can find there's quite a natural mapping between your functional tests and your company's user stories. And the way we tend to, well, we did these at Python Anywhere, is we'd write the user story out in comments inside our functional test. So we're going to have a user. I'm going to call mine Edith. Here's about a cool to-do list site. She visits it. And then we're going to basically interpolate these comments with actual commands to Selenium and actual assertions to our test framework to say what's going on. Don't type this now. Just watch. She sees the title and header. And so we're really describing things from the point of view of the user, and that forces us to think about things in that way rather than as programmers. So we're not really talking about functions and classes and views and variable names and values here. We're really talking about things the user can do and see. And so we're also going to learn a little bit now about what sorts of things Selenium can let you do to a website. So to do, we've got self.browser.title refers to the title at the top of the browser. We can also retrieve some information about the page. So we can do, and Selenium has a bunch of methods called find_stuff. And you can do find elements, which are HTML elements. And here we can go by tag name, h1. And instead of browser.title, we can do header.text. So the web driver can find elements. Those elements have properties including their text. You can also assert about HTML attributes, CSS properties, and things like that. And then we're going to have less of a little story about our user, and what we're going to want her to do is to come along, and she's going to be able to maybe type into an input box, and she's going to type something. We're going to try now. We're starting to kind of do programming by wishful thinking, where we're going to imagine what our user wants to be able to do before we actually write the code for it. And so on a to-do list site, okay, fine, it should say to-do so I know what I'm doing. There should be some sort of big input box where I can type in some text, and when I hit enter, some sort of to-do list should update with an item in that list. And if I do it again, I should get a second item. And we're sort of testing the ability to input text and also the ability of the website to remember things you've inputted before. So I'm not going to slowly type this all in front of you. I'm going to go instead and grab it out of a text file I prepared earlier. Zip 02. Yeah. Where are my send keys files? Excuse me for a sec. In the meantime, one thing you could do to save yourselves from doing a lot of typing is navigate online to my book's webpage, go and find chapter 02, and we'll be able to copy and paste this content. So obeythetestinggo.com, find the book, and navigate to chapter 2. Okay, once you find chapter 2, there's a listing in there that has a load of comments, and those are what I want you to copy and paste into your test file, which is like this. Okay, so once you get those comments, we're going to get these 3 little lines where it's going to go and fetch the header element from the page, and we can rerun that guy and see we still get that test failure to do not found in welcome to Django. Now, to actually get this to pass, to actually get Django to say something other than welcome to Django, I'm actually going to have to write some Django code. So you'll probably be pleased to hear that we're now going to move away from just installing software and writing functional tests to actually writing some code and some functions in our first view. So Django uses a sort of loosely MVC pattern. Put your hands up if you've never heard of MVC. Okie dokie. Put your hands up if you have heard of MVC. Can you explain it in a single sentence, sir? Model view controller, that's right. So this is a way of structuring applications that says you should have a model for your data, that's the model layer. You should have a view layer, which is the way that the user is going to view that data and interact with it. And you have some controllers, which are ways of interfacing between the two. When someone does something in the view, like input something or click some buttons, how do we transfer that into actions in the model? And then how do we retrieve stuff from the model and display it in a sensible format to the user? Django sort of does that, but it has a structure which it calls model view template, where the views are functions that are kind of like controllers, whatever. The important thing to us is that models represent database objects, and we're going to do them in the second half of this tutorial. Templates represent HTML pages, and we're going to do those in part 4 of this tutorial, where this is part 3. But the interesting thing is views, which are functions, and it's a function whose job is to process a request. So a request is when a browser requests something from the server. And the server's job is to say, okay, let's look at this request, see which URL it was asking for, and then I can dispatch it to one of a number of possible view functions, and those functions are going to take that request, process it, and return a response back to the user. And that response is an HTTP response, which is basically going to be some sort of web page, some sort of HTML. So that is the piping we're going to work with today, is view functions, and secondarily, URL mappings, which says, for this URL, I should use this view, for this other URL, I should use this other view. So the URL we're currently working with is the home page, and we're going to build basically a view function for our home page. And so we're going to move away from doing functional tests, and you notice I'm talking about functions and I'm talking about code now. We're moving down to the unit testing layer. And again, terminology here we can have arguments about, but unit tests are really about testing your point of view, not from the point of view of the user, but from the point of view of the programmer, from the point of view of your code, from the point of view of variables and functions and things like that. And so Django, because it's an enlightened test framework, is going to encourage you straight away to start building views as soon as you create your first app. So Django tends to structure or encourages you to structure your projects into projects. A project represents a website, and within a project you can have multiple apps. And so an app is meant to represent a bit of self-contained functionality. So we might have an app that represents the to-do list part of our site. We might have another app later that represents accounts and login. You might have another app that represents forums. And what Django is trying to do is saying, make some self-contained piece of code, and then you might one day be able to reuse an app that you've created for one project on another one. Now, I've never actually done that in real life, but it remains a good way of structuring your code. So we've got a project, which is our whole website, and we're going to start an app. And the command for that is python manage.py start app, and I'm going to call this one lists. And once I've run that, I'm going to get a new folder next to the superlists folder. It's just called lists. In there, we get a number of files by default, admin.py, models.py, we'll see that later. But of immediate interest to us is a file called tests.py. And this is where Django is encouraging you to put your tests, unit tests in this case, for this project. So I can go and have a look at them. Tests.py. And it says from Django.test import test case. And so here I'm just going to try this out. So imagining I've not used Django much, the very first thing we might want to do when we get a new type of test is just check that it all works. So I'm going to have class homepage test, inherit from test case, and test smoke test. Self.assert equal 1 plus 1, 3. So I'm just writing a dumb test that I know is going to fail here. I'm going to say, does 1 plus 1 equals 3? I'm expecting it to say no, but this is just a way of making sure that I know how to run my tests and I know they fail. And to run the test, I go manage.py test. Okay, good. So I've got this test smoke test, 1 plus 1 is not equal to 3. So could you guys do that for me, which is run manage.py start app lists, run, open the file called test.py, and then put a kind of dummy test that you know is going to fail in there, check that 1 plus 1 equals 3, and then make sure that you now know how to run both types of tests in your project. You can run the functional tests with Python functional test.py, and you can run the unit test with Python manage.py test. If that was a little bit much to keep up with, this is the topic of chapter 3 in the book. So if you've navigated to the book, everything I've just said is kind of described in chapter 3, including every single command, every single thing you have to type in. And I want you to get to the stage where it's saying 1 plus 1 or 2 not equals 3, something like that. Na, 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 na. All right. Okay, everyone, it's 10 past 10. The official break time is at 10:15, but they specifically asked me to make sure that you were let out exactly on time because the food tends to go. So, because we're at a reasonably natural break time, why don't we break sort of 5 minutes before the break, and that way you guys can get in on the coffee and biscuits nice and early. Please come back. Would you like 10 minutes or 15 minutes break? Yeah, yeah. Did I say biscuits? Yeah, yeah. Well, they probably are cookies, unfortunately, and not biscuits, so sorry. But yeah, there are cookies or cakes. Maybe there's cakes. Shall we come back at 25 past? Or even 20 past? Or 25 past? Hands up for 20 past. Hands up for 25 past. There's a slight edge for 25 past. Let's do it. Okay. But 25 past sharpish, I would come back at 24 past if I was you, because you've got to allocate time to getting back to your seats and unlocking your laptop. check, check. 1, 2, 1, 2. All right. Well, and okay, open right now. All right, everyone, welcome back. My name is still Harry. Thank you very much for coming back for the second half. You obviously haven't had enough punishment. So before, what we're going to do next is actually write a test for a Django view function, and write a Django view function that's going to return some raw HTML, and then we're going to get into a little bit of refactoring. So maybe take some code that works and then change the implementation so the tests still pass, but we have an implementation that we prefer. And then with a little bit of luck, we might even get into some database stuff near the end of the tutorial. But no matter how far through we get, this tutorial is based on a book, and I'm not sure I've mentioned this, but I've written a book about testing in Python. It's available for free online at betatestinggo.com. You can read all this. So when you get home, you can revise all this, and if you've liked it so far, you can go ahead and reread the stuff we've done, really embed it, and then there's another 20-odd chapters of content on TDD. And it's not just testing, it's also Django, it's also web development, but it's also like how to deploy your application onto a server and how to use the tests and run them against the server instead of running them on your own machine to make sure that your deployment works, how to automate your deployment, how to use Git and version control and how that interacts with the TDD workflow, how to set up a continuous integration server, how to do mocking, how to do good mocking and bad mocking, as much as I can say from my 10 years of experience, which is not a lot, and so on, and pointers to further reading. So that is all available in my book. Did I mention? I wrote a book available online. It's called Test-Driven Development with Python, also known as the Testing Goat book. Who knows about the Testing Goat? Yes, there you go. You've got to obey the Testing Goat. This is a dumb thing, but the Testing Goat was Python's unofficial mascot for testing. And I like to think of the Testing Goat a little bit like one of those in cartoons when you get a little angel or a little demon popping up over your shoulder. Like one of those, except with a very niche set of concerns. And saying, test first, test first. There's a little goat in your head reminding you to do things sort of thoroughly and properly. Because the thing about testing is it is kind of like an investment. You invest in doing some code that's not actually what you set out to do. And the reason you're doing is for a payoff that's going to come much later. So when we get to refactoring, if I don't mention the bucket from a well analogy, someone put their hand up and ask, and A, you'll get a prize, and B, you'll get a nice analogy. But that's the thing about testing, is it like you put in some effort now, but you get payoff later, which is that you're able to refactor your code, you find bugs that you didn't expect, you prevent yourself from getting regressions, but it is something you have to force yourself to do, especially at the beginning. After a while, it becomes second nature. All right, so we have got functional tests, which test our application from the user's point of view. We have now just started writing some unit tests, which are actually going to test individual bits of code from the programmer's point of view. And the individual bits of code that I want to write now is a Django view. So I'm going to test my home page. Home page. Now, we can do this at a very low level by kind of importing actual functions, creating request objects, passing them into those functions, getting things back. But Django gives us a couple of shortcuts for making requests from the Django framework. And it gives us a tool that's a little bit like the Selenium self.browser, which is self.client. And that's Django's test client that's able to talk to your kind of Django URLs and views. And just like we did self.browser.get, we can do self.client.get, and this is going to actually directly call Django functions rather than using a web browser to do it. And here we're going to just get the sort of home page. So I'm going to do self.client.get, that's going to give me back a response. So the testing framework is going to create a request, fetch the homepage URL, get back a response, and then we can make assertions about that response. And the assertions I want to make kind of correspond to the current place that the functional test is failing. And the current place the functional test is failing is here, which is saying, right, my current failure in the functional test is the browser does not say to-do lists. So in the unit test level, I translate that into programmer speak, and I know that means to get that browser title to say something about to-do lists, I need to return some HTML that has a title tag that says to-do. So what I'm going to be able to do then, so the way to translate that to my functional test is that I should have something like title to-do lists. You will almost definitely run into some dumb mistakes, or I will, to do with capitalization. So I think it's capital T, capital D. And that's going to be response dot. And so a response represents the response that's sent back to the browser. And if you know the HTTP protocol, you know that a response has some headers which say stuff about cookies and what kind of response it is, and it also has some content which is the actual thing the browser is going to display. In our case, it's going to be some HTML. And so that is called the response.content attribute. And we're going to call .decode because content represents some bytes, which is ones and zeros. And to change some ones and zeros into a Python string, we need to decode those bytes. So say, we decode it according to an encoding. So by default, it's UTF-8. So that's the text encoding, which is how you translate ones and zeros into strings. So response.content is ones and zeros. Response.content.decode is a string. That string is going to be some HTML, and I expect it to have this sort of thing, title, to-do lists. And then I might also just check that, say, it starts with HTML. So we're going to say response.content.decode.starts with HTML. So to make some more or less valid HTML, I can check that it starts with HTML and then it ends with close HTML. All right, I'm going to put these into this order. And so you can see that here now I'm looking at like ones and zeros, I'm looking at strings, I'm looking at bytes. I'm no longer really testing this from the point of view of the user. I'm testing this from the point of view of the programmer. So that's my, don't worry about typing this, I'll show this code back on screen in a minute. That is my unit test for the view. Let's run that. So how do I run the unit tests? There's a prize for this. It even says it on the screen. Well done, thank you. Very good. Slightly dumb error message here. False is not true. But I can sort of start to get working based on that. I could also put this one further down and take a look here. Blur up. If I do the assert in, all right, to-do list is not found in the requested URL was not found. So what that's saying is Django doesn't know about the URL slash. So I need to actually tell it, okay, well, who's going to be in charge of my home page? What view function am I going to have? So there's two files that we need to edit. One is the URLs file. Now URLs looks like this. It should say URL patterns equals URL something something something. If this, when you get to this file, it says path, then you've installed Django 2 instead of Django 1.11, and I have not yet had time to look into Django 2, so we might have to do a bit of debugging together or kind of hack about and start again from scratch with 1.11. But anyway, the URLs file's job is to map between URLs that a user might request for, slash for the home page, slash user, slash Harry if you've got a user's page, slash lists, slash list number 1 for different lists in our to-do list website. And it maps those URLs that different users might ask for to view functions, which are functions that take requests and return responses. So I don't care about admin. I'm going to delete that. I'm going to just make this, so in Django 1.11, views are represented by regular expressions. If you don't know what a regular expression is, let's just ignore that for now. You can enjoy that particular can of worms at a later point in your life. But just assume that this magic works. We start with a little hat $, and I'm going to say that should be views.home home page. Okay. So I'm going to have a home page, and I'm going to expect that to lift in from list.views import home page. And so again, I'm doing a little bit of kind of programming by wishful thinking here. The first place, well, my test was wishful thinking, saying if I get this, I should get this. And secondly, I'm going into urls.py, and I'm saying, all right, well, my homepage URL, I'm going to want it to use a view called homepage. I haven't even written that view, but I'm going to write the import in here. And in the kind of unit test code cycle, I really want us to go in tiny little incremental steps. So that's the next thing I want to teach is this kind of unit test code cycle where we write a test, and then we write the smallest piece of code that can possibly address the current failure. And the current failure is there's no such URL as the home page. You know, I'm getting a 404, I'm getting a page not found. So the very first thing I can do is let's start defining my page not found. So I've really only written 2 lines of code here, this one and this one. And if I rerun my test, what will happen? Yep, that sounds right. Let's have a look. Sure enough, import error. So I've imported something and I haven't even defined it yet, but that's okay. So these are the kinds of tiny little steps that you can go through when you get into TDD. And you might think, this is pointless, come on. And yeah, sure enough, I'm going through really, really tiny steps, and you might use slightly less tiny ones when you come to real programming. But you would be surprised at how small the steps are that I use and my colleagues use and people who do TDD use. Once you get used to it, this thing of jumping between running the tests and your code and running the tests and your code actually becomes a very smooth workflow. And by going through these tiny little steps, you make sure of 2 things. You make sure, 1, that your tests cover every single piece of code that you write, and 2, you make sure that you don't start writing loads of code that's wrong, and waste loads of time. So it just keeps you on track. So the next place I need to go is in views.py, and I'm going to write, so how do I address the current test failure? So the current test failure is this one here. Import error, cannot import name homepage. So what is the smallest little bit of code that I could write? Let's be good about this. What's the smallest piece of code I could write that will get this? Yes, sir. Yep, I've got a file actually. Views.py exists. Okay, so what should I put in here? Tell me what to type. So in pair programming, sometimes you have a driver and a typer, and the driver will say, now we need to do this, and the typer will sort of type those things. So what do I need to put in here, sir? Def homepage request, not bad. I can do even more minimalist than that. Look. Now, okay, listen, there's working incrementally, and then there's crazy, and this is kind of crazy. But I'm just demonstrating that, look, your test can actually tell you at every single stage of the way exactly what you need to do. So I've done homepages now, which is a homepage equals none is obviously wrong. But I rerun the test, so I've made a small change, and look, the error message changes, and it's even going to help me to get the right thing. And it's saying type error, view must be a callable or a list tuple instead of that. So view must be a callable. All right, so already I can get the test to tell me that homepage equals none doesn't work, and I need it to be some sort of function. So what should I do instead? There you go. Should I take any arguments? No, excellent. All right, you guys have got the hang of this. Fantastic. There we are, and we'll get rid of that. Look at my super minimalist views here. And we'll rerun the test and see what they say. So I've got a homepage. Now, if I'm a Django developer, I know that view functions always take the request as an argument, but just for the sake of demonstrating this, look, the test will help me and say homepage takes 0 positional arguments, but 1 was given. So it's saying, I tried to call your function, I tried to give it an argument, it wasn't expecting it, your function signature is wrong, you need it to take arguments. So you see, at every single stage, the test can tell you exactly what code you need to write. And that really makes sure, if you're doing it this way, it makes sure it's the tests that are driving the code that you write. And that ensures that you're well covered in your code base by tests if you only permit yourself to write minimal amounts of code and only permit yourself to do it once there's a test that's failing. So I'm going to put an argument in there. Boom. And so I've still got pass, which is returning nothing. And again, I get a really helpful error message. So list.views.homepage didn't return an HTTP response object. It returned none expect. Look how helpful Django is being, really telling you exactly what you need to do here. All right, so we need to return an HTTP response object. I happen to know that we import that from django.http import HTTP request. Nobody can type while somebody's watching them. HTTP request. And I'm going to return an empty one. All right, so that is the smallest amount of code. It wanted me to return an HTTP request. I'm going to do that. And great. HTTP request has no attribute get. I wasn't expecting that. Thank you very much. Yes? All right, this is why. You might not be able to type, but at least you have some people in the room that can help you when you make stupid mistakes. All right, HTTP response, yes, my apologies. Fantastic. And so now we move on. At least the framework is happy. It's saying, all right, all your piping is done. And now we get to the actual kind of test failure. And it's saying to-do list is not found in the empty string. So my HTTP request is just returning empty content. And so now I can start going a little bit faster. So I'm going to go, it doesn't have title. So I can go to-do lists, close title. All right, write the minimal code, write the test. False is not true. It's saying response starts with HTML is not true, so I can do that. HTML, zip. Tiniest little bit of code, run the tests again. Another false is not true. Response content decode ends with HTTP. And then I'm going to go in here and go close HTML. All right, so I've got a title that says to-do lists. Rerun that, unit test pass. So, a round of applause for me. Yes, absolutely. Thank you. Thank you. I'll take that. Yes, thank you. Thank you. Hooray. But you see, we went through that, like these tiny little incremental code changes, and you find that unit tests will drive that code at every step of the way. And what we're doing here is double loop TDD. We've got a little loop of unit test code, unit test code, unit test code. So that loops around. And once we get our unit test passing, we go, gosh, I've forgotten what I'm doing. What do I do next? One of the nice things about this setup with functional tests and unit tests is that if all of your unit tests are passing, the next thing you do is just go back and run your functional tests, and they remind you of where you'd got to, or they will tell you if you've gotten a little bit further. So let's see if I now rerun my functional tests, have we got a little bit further? Have we produced something useful? And we get All right, I get some sort of exposure here. Oh, I think I lost my run server. Okay. So if you see that error, it's because your server isn't running. That's totally possible. Okay. Fine, server's not running. Let's get it running again. Now what happens, Django? Unable to locate element H1. So that is still a failure, but notice that that is a different failure from the one we were running before. And here's another skill that we're going to learn in TDD, which is reading tracebacks. So sometimes you get like a big kind of traceback like this, and it's kind of confusing, and like what is actually going on here? So there are 3 things you need to do. First of all, you might just notice you might just look at the error and immediately know what's wrong. So that's the first place to look, is that error, unable to locate element H1. If that doesn't completely put you on the right track, go back up and check which line of code or which line of test has caused this problem. So here we're going to have a look, and at the top it says functional test line 18. So we can go and have a look at functional tests. And line 18 is here. And so that's quite nice. That's telling me that we've done the self.browser.get, we've visited the home page, we've done self.assert in browser.title, and it's got past that, and it's got to the next stage, which is looking for the header. And so my HTML only has a title, it doesn't have a header, so it's failing here. But that does mean that I've got this particular assertion to pass. So my functional tests have got one step further as well. So I can congratulate myself for that. And that's what I'd like you guys all to do next. Get your functional tests one step further. And I'd like you to do that by building a unit test that looks a little bit like this, and a home page that looks a little bit like that. You'll also need urls.py. Don't know if I can show all 3. Let's try it. Okay, not quite. No, okay. All right, so I'll show you these 2, and you can write the views.py on your own. So that's the next stage. Change your unit test into being an actual test using self.client.get that tests your view function. Wire up urls.py to call your new function, and then go through these tiny little incremental code steps where you go and you make the minimal code change. Go through that home page equals none and see if it really works. See if at every stage the unit test will drive you to writing the next little bit of code. Any questions before we jump into that? Prizes for questions, remember. Okay, good. Carry on. Hands up if you've not got this. All right then, let's move on. So, yep, thank you, Tyler. Check, because I'm not loud enough already. Okay. So let's move on. Right, we've gone through our first unit test code cycle. So writing tiny little incremental bits of code and letting the unit tests really drive that code. And then we've been able to go back to our functional tests and see that they get one step further. So if we imagine our unit tests driving little bits of code in the individual functions, we imagine our functional tests kind of driving kind of larger levels of granularity of code. And the functional tests are currently failing, saying there is no header on our page. And so we might want to move on from that then and say something like, okay, unable to locate element h1. So to get that to pass, I might go in here and start going, let's close this one. I'm going to views. Okay. So I might start kind of going and putting more like h1 elements in here and blah, blah, blah. But this is a horrible way of editing HTML. And everybody knows that. And so Django gives you a much nicer way of HTML. If you're writing HTML, it would be nice to be able to edit a file in your editor that ends in .html, and then we'll get syntax highlighting for HTML to help us to avoid silly syntax errors. And that is absolutely possible. So what we're going to do now is our current implementation of our view function uses a string to give HTML to the user. And we want instead to use a file, or what Django calls a template, which contains some HTML. And that is going to be our first refactor. So we're going to take some code that works, as in our unit tests pass and our functional tests get to a particular point. And we're going to refactor that code, make it have a different implementation that delivers the same result. So that's who would have a good definition of the word refactoring? Hands up if you know what refactoring is. Okay, you sir, over there. Can you define refactoring? That's right, updating the code without the behavior. And so do you need tests to do refactoring? Yes, you do. If you don't have tests, then you're not really doing refactoring, you're just doing messing about with your code, which is fun, but it's not refactoring. And people have written whole books on like the super structured methodical way that you should do refactoring in ways that will minimize the chance of you messing it up. We're going to do something a little bit like that today. We're going to take our homepage view, which uses a raw string, and we're going to make it use a template instead. So the first thing to do is take a note of where our functional tests are failing. They are failing at line 18, as I recall. And then we'll just rerun, before you start any refactoring, just run your unit tests and make sure that they all pass. So like step 1, do I have passing tests? Yes. Okay, good. So step 2, I can start messing about in here and doing a little bit of refactoring. So I'm going to maybe take that. I'm going to make a directory inside list called list/templates. I'm going to go lists templates, and I'm going to have a template called home.html, and I'm going to paste this stuff in here, and I'm going to have my HTML. There you go. All right, so you can see I now get some nicely syntax highlighted HTML, and my editor is doing helpful things like, indenting it correctly and so on. And so now I've got HTML title to-do lists. So there's a nice file. And then how do I actually use that template in my view? I'm going to go from Django.shortcuts, and depending on how you tidy up your file, that might still be in there. Import render. So render is a function that takes a template and renders it. And I'm going to call render. The first argument to render is the request object, and the second argument is the name of a template. Home.html. All right. So that's my refactor. I stop using the raw string. I put it in a file called list/templates. I'm going to run render request home.html. Let's see if that works. Manage.pytest. Template does not exist home.html. What? That's weird. Okay, well, let's have a look. Here's my tree. Find dot minus name star dot pike minus pipe to xargs rm. Okay. So I have definitely got a file called home.html over here in the templates folder. I know my Django, and I could look up in the documentation. Django says, I will automatically find any template inside a folder called templates in any of your apps. So I'm pretty sure that's in the right place. So I've got a slightly inexplicable test failure there. Template does not exist, home.html. So what's missing? And after a little bit of debugging, you might find out that although we've run python manage.pystartapp lists, when you tell Django that you want to start an app called list, you actually need to tell it a second time. You tell Django twice, and the second time you tell it is in settings.py. So settings.py, there's one of these for each of your Django project. It says it holds kind of global configuration for your project, and one item of that global configuration is what the installed apps are. So you'll find a line about halfway down in settings.py which says either installed app. It has some default Django apps that do stuff, and I'm going to install my new Superlists app. Up until now, it's not really been properly registered with Django, but now that we want the template loader and other Django machinery to actually find it, we need to put it into installed apps. So pop, we put lists into installed apps, we rerun our unit tests, and then, depending on your text editor, you may or may not get this failure. But so this is an unexpected failure. And before we've had expected failures where we've written a test and we've run it and we've seen it fail because we were expecting it. And this is unexpected. And so we're going to go, okay, that's a bit confusing. But again, we do our reading, our traceback. We look at the error message. Does that explain it? False is not true, does not. Then we go back into see what error is it, what line of code is actually failing. Line 14 in our test. Let's go and have a look at that. Tests. Line 14 is this one. It's saying, okay, I've got this far. The response does start with HTML. It has title to-do list, but it does not end with close HTML. So that's surprising. It was working before, and when I moved to using a template, it doesn't. Now, it definitely does have HTML at the end here. So when you get an inexplicable test failure like this, you can do a little bit of test debugging. There are different techniques, but one really dumb one is just print-based debugging. So here I'm going to go print response.content. And so I'm printing that just before the test failure. And I see in some output, it's printed out. It's got this little B in front of it, which means these are bytes. And so I've got HTML, backend is a new line character, a few spaces, title, to-do lists, all right, I'm expecting all of that. Another backend for a new line character, close HTML, and then look, it's got this trailing little backend, \n there, which is that when I switched from using a raw string to using this file, my text editor added a new line character at the end. So strictly speaking, this little test here, it doesn't end in HTML, it ends in HTML backend, like that. And let's see if that passes. Fine, it does. Okay, so that's a dumb little thing. I don't really care in my test whether or not there are new lines at the end of the HTML, so I'm going to call .strip over here. There you go. Shoop. And then I no longer need this print.
Harry,
Yes?
so when you did the browser title,
Yeah.
you were able to put browser.title and you got a better debug message. Is there an alternative suggestion?
Yeah, for ends with. So you can, that's a really good question. Wouldn't it be nice to get some, so there is a second argument to most of the unit test assert methods, which gives you a custom error message. So when you have assert equal unit test or assert in, unit test will automatically say, oh, well, I didn't find this in that. But here I've just got a truthy statement where I'm using Python's .endsWith method, which just returns true or false. So we have this second argument, which is a bit like the second argument to a search. So then we can say, and we can pass a custom error message in here. We can say HTML did not end correctly, full stop, was colon, and I'm going to put response.content over here. Boop, boop. I'll make this an F string. F strings are really useful for test debug messages like this. And if I get rid of the strip, let's see if that works. Choop, choop. HTML did not end correctly, and now my test is actually telling me the specific thing that went wrong. I can see the back end in there. So good question. The second or the final argument to any unit test assertion method is a custom error message if you want one. And I'm going to put .strip back in here. Make sure it passes. I see you. And we're OK. Yes, sir? Oh, good. Good question. F-strings are a new feature of Python 3.6. So if I prepend a string with the letter F, then I can use this syntax here, which is put curly brackets in, and it's going to interpolate the value of a variable. So basically, I've put response.content, and what it actually printed when I ran the test was, the actual value of that variable, response.content. So it put me a string with that bytes in. So it's the equivalent of doing was colon plus response.content. Yes, %s still works. You can also use dot format. So people started to suggest you could do like, thing, and you go dot format thing equals. So it's basically a kind of version of this syntax here, but it directly finds all of the local variables and puts them in. So I just put response.content in there. It's really convenient. It's a dumb little feature, but it's one of the nicest things about Python 3.6. And once you start using it, you use it all the time. So f-string response.content. Little diversion there. But okay, my unit tests pass. So I've done a refactor. I moved from using a simple string to using a totally different implementation. The unit tests guided me through an unexpected failure, which is that you only find templates if they've been added in settings.py, if the app's been added in settings.py. And I'm back to a working state as far as the unit tests are concerned. So let's rerun the functional tests and see if they get a little bit further. Yes? Did not work. Will you just put a pin in that? I'm just going to finish this bit. Okay, so we're in the same state. The functional tests are failing at the exact same point, which means I know my refactor hasn't broken anything, I haven't gone backwards, I haven't had a regression. And so now I'm at liberty to say, okay, we can add maybe an H1, and we can wrap this in a head, and that can be an end head. And then you can be a body in here. And here I can go to do lists and H1 and body. And so this brings me up to a good question. You can see I'm doing a lot of typing here, and I'm not flicking between this file and running unit tests. So whenever I wrote Python code, I would always be, let me write a tiny little bit of code, run back and run the unit tests. How come I'm feeling free here to just type away in this HTML file without constantly running tests? And this gets into a little bit of testing philosophy, which is, how do I decide what I need to write tests for and what I don't? And there's lots of rules of thumbs about that, but one of them is don't test constants. So if somewhere in your code it says foo equals 3, it's kind of pointless to have a test elsewhere that says assert foo equals 3, because then you've done something that doesn't even have as much value as double entry accounting in accountancy. That's just pointless. Having a test that is exactly the same as your code is a waste of time. And the other way of putting that is sort of test behavior, don't test implementation. The equivalent of saying foo equals 3 is saying my HTML template is the following string, or it's this file over here, and I think of that as just a constant. And so I don't feel like I need to write unit tests for every single line in an HTML file. So similarly, if you've got constants in your code, don't go writing tests for those. Instead, test the effect that those constants have. And the way I'm testing my HTML is, am I producing HTML that produces a page that the actual Selenium tests can use successfully as far as the user is concerned? So I don't need unit tests for templates, and my functional tests cover, do they have the right content? Does that make sense? That's the don't test constants rule. Yep. Later on, in templates in Django, you can have code and you can have logic. You can have ifs and for loops. And so you could, if you felt like it, start saying, well, maybe I should test the logic of my templates in that case, but that's debatable. All right. So that's what I'd like you to do today, or just now, which is switch from having that string implementation to using a template, see if you hop through those kind of unexpected failures, and get back to a working state and get a little bit further in our tests. And there was a question over there. Yes, sir. Yep. Good question. Actually, that prompts me towards saying, so we've done really well at refactoring our code, and the code is much nicer. I'm now rendering a template, and when I want to edit my HTML, I can edit it in a template. And this is much more explicable code. But similarly, my tests are kind of awkward and unwieldy, and we're doing these things like .strip and .decode, and really, this test is sort of long-winded, and we're testing very specific things about the constant of our template, so we are effectively testing a constant here. And what I don't really care specifically about what individual blocks of HTML are, the HTML is kind of a constant, what I really care is that the home page should render the correct template. So I can refactor code, but I can also refactor tests. When I'm happy that I've got an implementation that works, I can just add a new assertion in here that says self dot. So rather than like asserting on the raw HTML, I could say, did the home page use the correct template? And Django gives you a way of doing that, which is assert template used, template used, response, comma, home HTML. So this assertion says, okay, when Django gave me this response, along the way, did it use the right template? And that's whoops, wrong test. That's a tool that Django gives you. Python manage.pytest. Okay, so that passes, so I know it got bad. Just whenever I get a test that passes and I never saw it fail, I'm a little bit nervous. I don't know if I've just actually written assert 1 equals 1. So I'm just going to go blah.html, deliberately make the test wrong, have a look at that. Yep, blah.html was not used, actually used home.html. Good, that reassures me. Fine. So I know this assertion is working, and actually once I've got that, I can get rid of all this, because all I really care is, did I use this template over here? And then the specific contents of that template don't matter as far as the unit test is concerned. This view needs to render this template, that's all it needs to do, and the test should reflect kind of the behavior that I want from the view rather than the specific implementation, which is what is the specific text. So that's refactoring the code, and then later refactoring the tests. So I'm happy with that. And that's to make sure that I didn't break anything, I can rerun the functional test. Fantastic. So that's what I'd like you all to do now. Switch from using the string implementation to the template implementation, and then get a little bit further in the functional tests and refactor not just the code, but also the tests. There you go. So I assume these power issues was due to dodgy African power, but that was very parochial. In fact, it is my laptop that's dodgy.
Right.
Let me just, oops, sorry. Let me just check there.
Actually, is there an HDMI port on the side of that guy?
Yeah, there is, yeah.
HDMI?
Yeah, you got HDMI. Just take all of that.
Just to try it.
Let me just change the backdrop first. Why is it not going
So,
up the
so
settings?
nothing's going to come up on the screen right now? It's just going to show up
Oh,
on-
great. Okay, let's do that then.
You actually have HDMI out on those things?
Yeah.
Wow.
Set to 1080.
Yep. How do I do it? Wait a minute. Oh, it's up there actually.
Scale, please. Hit scale again.
Well, that's exactly what happened here.
Try that one again. 1600 or 1200? No, that's too big.
I can.
No, that's still a 4:3 image, not a 16:9.
Yeah. No. Yeah, that should be. That's a wide one, isn't it? It is.
Refresh rate. Can I
Oh yeah, sure.
check that for a second? Not still
No. Oh, nice. Do you want me to 1600 by 1200? Actually, that's not right, is it? That's 4:3. So yeah.
It doesn't matter.
No.
This is because our records are set up for 69, so I had black borders on the side of that 4:3 image.
Right.
Okay. So you can get set up on here.
Yeah. It's basically just that it's been showing, isn't it?
So this is how it's going to look on the display.
Yep.
On the screen too. Okay. And this is also going to go to record once I make it live. So
Yeah.
I'm good to send it. Or do you want to
Just give me a second to clean up the this. Why is this not working? PS1. never mind. We'll just go with that.
Okay,
I think that should be okay. Yeah. Whoops. Where can I plug in?
There's a power port right up here. Is his laptop still plugged in? Yes, it is. And I don't have a spare port.
Oh, he's got an adapter in here already. So.
Yeah, he's got the.
Well, I guess he's charging. So
He's charging out. He's got the UK adapter there.
you know what? This can do both at the same time. So. It's the most amazing adapter in the world. I can plug anything to anything.
Oh, jeez.
So this is like to take US as well, or it can take European.
That's really neat. I've got just a feature film one, but you can do just one in and one out.
Yeah.
But you can go anything in and anything out.
So yeah, this just does. You can do 4 basically, plus two USB ports. So, yeah, the first time somebody at a conference at Lightning Talks, not Lightning Talks, the sprints pulled one of these out and was like, "You can share mine." That's amazing. I'm just trying to remove all the piracy sites from Firefox now.
I don't think he's going to see Firefox though. We should never actually see it go on screen.
Nah, that's all. Okay.
You should get a burner laptop then.
Well, I've got a work laptop, but the keyboard's broken, so this is actually my personal laptop. But
I should have brought my burner laptop and I wouldn't have had to use it. So that's that. Can I run Tmux on here? Have you got Tmux installed?
No.
Okay, so
You can try it.
yes, I
There
do.
we go.
Yeah, fantastic.
Probably
So how do I
double
open a second terminal window?
So actually, there's 3 open now already, and if you want to switch between them,
1, 2. Okay, everyone. I think you're all through this. Hands up if you didn't get through this little bit. No good? All right, in the next stage, we're going to move on to actually trying to interact with our website. So we've managed to create a site. It's up and running. It can display a static page. You can say to-do list. Hello, Jason.
So is the request object the HTML that's being returned? What's the difference there?
What request object?
Well, we did render request, but like where's the actual HTML coming from?
Okay, good question. So let's have a look at... also, I've just had a little last-minute laptop change here because mine ran out of batteries. I'm presuming the font size is a little too small here. So I think Command-Shift+. Okay. And then CS default. Yeah, okay. How do I change the background over here, Mark? I might be able to change the color scheme to something better. Okay, you change the background color. So the question was, what is this request object and where does our HTML come from? The render function finds the home.html template and it's going to return that. Why do we pass in the request is because the render function, when it's returning a response to the user, it also grabs some information from the actual request and uses that to generate the response that goes to the user. And that includes some stuff about if the user is logged in or not. Django will manage that for you, what cookies they have, whether they have a session, things like that. So that's why the render function needs to know about the request. And the response is the result of the render function, which is what we do, which is what we return. Yes? It becomes part of the, no. So the request object is kind of like ignored from this point on, and what we get back from the render function is a response object. So that would look like this. I could rewrite it like this. And that. HTML from home.html, and then basically do return response. So if that makes it a little bit clearer, render gives me back an HTTP response object. That HTTP response object is produced using the HTML from that template home.html, and that's what we return to the user. Yes, sir. Yes. Just the content. Yeah. Yeah. And so home.html, so Django has templates and it allows you to build a hierarchy of them. So you can build a base template and you can build child templates, and you just give Django render the child template and it looks up the base templates, clumps them all together. But once we have a response object, all of that has is a .content attribute, which is some raw bytes of HTML to send to the user. Yes? As it was just to make an explanation here. The code I actually want is this. Yep. Okay, is this font big enough? Should we embiggen it a tiny little bit more? Command-Shift+. How about that? Is it readable? Don't say if what you mean is. Okay, good. All right, so in our functional tests over here, so I'm going to start. We've got as far as this. We've managed to make a header, and we're going to get into the next stages. And we're going to actually start to want to flesh out this functional test and get it doing some stuff. Now, I've copied and pasted this stuff from Chapter 4, and you guys can do that in a minute. I'm not going to ask you to type this all in. But we're going to get into some of the other things that Selenium can let you do. And so far, we've done find element by tag name, which takes some HTML and finds any tags in it. And we can also do find element by ID. So you know in HTML, you can give an element an ID. It's supposed to be a unique element. That's another way you could retrieve something. So I'm going to assume that there's an element with the ID, ID new item, which represents the input box on the page. And we can do things to that, as well as looking at the attributes of that element, like what is its text. We can also do things to it. So we can get its attribute, like the placeholder. So you know in a text box, when you have some grayed out text that says, enter something here, that's the placeholder attribute in HTML. And it says enter a to-do item. So this is the kind of user-focused kind of testing. It's saying like, what are the helpers we give the user? So the user should see in that input box, there's some placeholder text that says enter a to-do item. And the next thing we're going to do is call this send keys function on an HTML element, which is actually going to simulate typing into the element. So in the old days, Selenium used to work with like JavaScript, and it would try and send keys, and it wouldn't work, and all your JavaScript listeners wouldn't work properly. You'd have to trigger them manually, blah, blah, blah. Selenium is now much better, and so when you do .send keys, that really does type those keys into the browser and simulate the user typing in. And if you've got some complicated client-side JavaScript GUI stuff that is waiting on key presses, all of that stuff's really going to work. So Selenium is going to actually type into this input element the following characters, and then we're going to do send keys, keys.enter. So Selenium has got ways of sending special keys. So if you want to do Control or Alt or things like that in your elements, you can do it. And keys.enter is a special key. Depending on what platform you're on, you can also just use the \n escape new line character. And so this is saying, all right, I'm going to type in the first item in my to-do list. Edith is a keen fly fishing enthusiast, so she's going to buy some peacock feathers. That's what we're saying she's going to do. And then in step number 2, later in the test, she's going to maybe tie them into a fly. Anybody here keen on fly fishing? It's my dad's thing. Yeah, one person. Awesome. So you can make fake flies out of feathers. That's one of the nerdy things you can do. Question. Yes. Did you have the question earlier, sir? Yeah.
How do you decide if, checking an attribute,
Yeah.
how do you decide if that's just testing a constant?
Yeah. Good question. So like how much detail you want to go into with your functional tests is really up to you. But here I'm just saying, well, listen, if it's really important to you that the placeholder text should be correct, then you might want to have this sort of test. If you don't really care, then don't ask about it. And what I'm really trying to do is make sure that the things I'm testing are things that are visible to the user and that the user cares about. But I might, you might say care that there's a link that goes to back to the home page. And so you could test that by going, is there a link that says home, and it says home somewhere in the link text, and I could click on it and see that I get back to the home page, but I might not assert, for example, the specific URL in the .href is this or that. So you have to try and say, let me test the aspects of the HTML that the user cares about, not the ones that are sort of implementation details. Does that answer your question? Yeah. Any more questions at this stage? All right. So we can extend the test like this. You can do it by copy and pasting. And once I've got that, I should be able to run it and get a little bit further along. And it's going to say self.what? Where does it say finish? I feel like I'm not editing the right file here. Yeah, so it shouldn't have. It should have failed around here. Oh, okay. No, here we are. Okay. All right, okay. I think I've cheated all the way to... all right, so here we've got a test. What's it doing? It's going to send keys, peacock feathers. It's going to press enter. The next stage we're going to do is say, okay, well, the next thing the user's going to expect is when they submit a new item, some sort of table or list should appear on the page which represents their to-do list, and it should have an item in it. And what we're going to say, like I've made a slightly convoluted assertion here, and it uses some funky Python magic, which I was very pleased with that for at first. And that, by the way, is a code smell. So if you find yourself writing some code and you feel real smart, that's probably alarm bells there. But what's going? Will you put a pin in it for a sec? What I'm going to do here is find a table, look at the rows in it, and say, okay, well, if I've got a to-do list, it might have any number of rows. What I want to do is make sure that there's at least one row in there that is row number 1, and its text is by peacock feathers. And the way I'm implementing that is I'm doing a list comprehension of, for each row in rows, assert that one of them, I say row.text is equal to that, and then the any function in Python takes a list of things and will return true if any one of them is true. It's a lovely bit of Python syntax. And here there's the error message saying if it doesn't find that, it will say new to-do item did not appear in the table. Wow. I feel so clever writing this. Later on, I'll find that actually it's more trouble than it's worth. And so the code smell there is if you're doing something too smart, go back to doing something simpler, because you have to be twice as smart as the person who wrote the code to be able to debug the code. So if you write some code that is absolutely as smart as you can possibly write it, you will not be smart enough to debug it. So try and write code that's about about half as smart as you are, or twice as dumb as you are, and then you've got a good chance of finding the bugs in it. Anyway, so this is saying, is there a table? Does it have my element in it? And this is currently failing because I just sort of jumped forwards in the code, but it's currently passing, and the reason is, what the heck is this? Okay. Okay. Line 50, finish this test. Really? Oh, which window is the server running in, Mark? The run server command is running in which shell? That'll be what's happening, actually. Let's close this one and just make sure it's running in the correct folder. Or is it gone now? Yeah, it's gone. Okay. Control B, N. No. Make a new window in tmux. Okay, let's just work on a new tab in the terminal. Command T.
Yep.
All right, great. It's gone up there. Print working directory. Uses mark cd. What was it? Docu. Dever. Harry. Okay. And then I want to go cd book example. And I'm going to pew. Work on. Workshop. Okay. Oh, that's bad. Okay. All right, let's make sure we're running the server that we think we are, and then I think there's a chance. Okay. Okay, awesome. Yes, great. All right, let's see that. Right, this is the error I expect. We're able to find the input element, it has the right placeholder, but when we click submit, it doesn't get submitted. And so the next thing I want to teach is really processing user input on the server side. So we've got a server that's able to return static pages. I want to now process post requests. So let's have a little check of where we are. This is our HTML. I'm going to add a new input element to it. I'm going to give it the right ID. I'm going to give it the right placeholder text. That's going to get my functional test a little bit further. Then I'm going to put an empty table in there that says the right ID list table. And then to get to the next stage, I'm actually going to need to write a view function that processes that request. And so I'm going to show you writing a unit test for a post request and getting that to pass in a hacky way. I'm going to hand over to you guys to make sure you have the right functional test, the right HTML, and the right bits and pieces. And once we've got that unit test passing in a hacky way, we're going to really implement processing a post request on the server. All right, so where are my unit tests? E-list test.py. So we've got one test that says test uses home template. So to actually get my server to process user input, so let's see handles post requests. I've actually put it into a form here. I'm going to do self.client.post. Who knows the difference between get and post on, or who does not know the difference between get and post in HTML? Yes, 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 yes. Fine. So a GET request is when your browser goes and says, get me this URL, please. Like when you type a URL into a search bar or when you click a link, that's a GET request. A POST request is when you submit information in a form. So when you've typed a bunch of stuff into a web page and you hit submit, it's a different part of the HTTP protocol. And that's one where the user is saying, not just give me this page at the following URL, but is saying, dear server, here is some information from this form. And your web browser gathers all the fields in the form, and they're usually key value pairs, so each field will have a name and a value. It sends them off to the server saying, please process this, and the server will decide how to process that. And the way we emulate that or the way we represent that in our test framework is instead of doing self.client.get, we do self.client.post. It takes a URL, and then it takes a dictionary, which maps kind of the names of your inputs elements to the values that the user has input. So I think our name is going to be called item text, and the value is going to be called like a list item, something like that. And a dumb test for this would be to say, okay, well, if the server receives a post request, let's just show that back to the user. And we're going to do kind of really incremental development, where we're going to start with a to-do list website that can handle having exactly one item. So, start with a moment we've got a to-do list website that can handle 0 items. So we're going to move to handling 1 item, and then we're going to move to handling n items. We start from the specific and we generalize. And then we'll slowly realize that we've managed to make a to-do list website that can handle n items, but there's only one list. So every single user that comes to the website has the same list, and then we're going to expand that out to having different lists for different people. Although the concept of having a single to-do list that's the same for every single person on Earth is, philosophically speaking, a thing that reminds us that we all share common problems like global warming or population, and we should think about that. So philosophically it's interesting, but as a website that's going to make us loads of money in the lucrative world of online to-do list sites, it's not much use. Anyway, so we can handle 0 to-do lists. Let's make one that handles 1. And so the dumbest sort of thing I could do is say, well, let's just display the user's input back to them, and that might even kind of get my test to pass. So I'm going to say, instead of assert template use, I'm going to say assert in, and I'm going to say, let's say, a list item. Response.content. All right, Control Z. Managed up. How do I run my unit tests, everyone? Thank you. All right. I've got my usual problem of using bytes instead of strings. Response content decode. All right, fine. So a list item not found in blurgle, 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 blurgle. So how do I get my view function to notice that something is a post request and not a list get request? Is I can do it over here. And so I could go, fine, if request dot method and I wonder if I can just do this. I need an HTTP response. Foo. So I'm just making something that's deliberately broken, but I'm just trying to make sure I understand how it all hangs together and can I actually deal with post requests and get requests separately. Import HTTP response. Okay, let's try that. Good. A list item not found in foo. All right, so I've got different branches now in my view for if the user has done a post request, I should do this. If they've done a get request, I do the same old thing. And so how then do I extract what the user sent me? It's the request object has a .post attribute, which is a dictionary of key value pairs, like that dictionary passed in. And so I'm going to go hooray. Okay, fine. So that handles post request differently. Let's see if that satisfies my functional tests. Okay, still no to-do list item found on the table. That's because that string isn't really going to work. And so the next thing that we want to learn is, okay, rather than just sending that piece of text straight back to them, what we want to do is take that piece of text that they gave us and put it into the template somehow. So over here, I'm rendering the home.html just raw. And the thing that we're going to learn now is that Django templates are special, and they let you take values of your Python code and put them inside your templates. And there's a special syntax for that, which is the list templates home.html. Incredibly easy to type, sort of double curly brackets. Later you're going to learn the Django syntax for template variables is the incredibly easy to type open curly brackets %, which is left pinky finger to your left shift, right pinky finger to the curly brackets, and then right pinky finger to the left shift, and then left index finger to the 5, and thank you very much whoever decided that that was going to be the combination. But for simple variables, you just go curly curly, and you can pass in a variable name here. And so we could say like new item text in here. And so what this template is saying is display inside this table. Actually, we need to make a row, don't we? tr, td, new item text, ntr. All right, so I've got a table with exactly one row. And I'm going to display the new item text if that comes out of my Python view. And the way we do that
is a list views.py. We're going to do a render in this case, request home.html. And the final argument to render is a dictionary, again, of names of variables to the values of those variables. So I'm going to say new item text is going to be the value of request.post item text. Okay, so there's quite a few variable names to keep a hang of here, but I'm making them different so you can sort of understand all of them. Item text over here is the name of the thing that the person sent to us in their form, and that comes from the form. Okay, so it's this one here. That is item text. And then when that gets sent to the server, that's the name that's attached to the user's input. And this variable here, new item text, is the name of the variable in the template that this render call is going to assign it to. So I can put anything here. This could be foo, but new item text is going to go in here. And that's what's going to appear in here. So if the user's done a post request, I'm going to create this new item text variable. I'm going to put it into the template. And let's check that our unit tests still pass. Great. And then maybe our functional test now will have a chance of getting a little bit further. All right. This didn't work. And so this is the final little section in this bit. Remember my super clever any function I told you was a little bit too clever? False is not true. New to-do item did not appear in the table is not an incredibly helpful error message. So we want to go into our functional test and give ourselves a more helpful error message to do debugging. And so we could put it in as an F string or something and go kind of rows.text. But instead, it might be simpler, rather than doing this clever inner function, to just do some sort of assert in. And let's say that this should be in row.text for row and rows. And this assertion is more readable and is more clever. So there's your lesson there about being too clever, often being a code smell. What's my syntax here, Sam? Oh, thank you. Fantastic. All right, so that's saying there are no rows in my table. That's surprising. Something's not working. And I know that unit tests are working. Write this one, edit that one. I'm sorry, yes? Let's have a look. This one here? Yeah, that's wrong. Yeah, hang on, that's more like it. I think I just put that in by accident, but when I actually run the tests, there's another one. Surely not. Or row. That was quite a good one. All right. So then the final thing is I've got my unit tests, which are telling me if I send it a post request, it definitely puts the right value into that render function. And I've got the functional test telling me, look, listen, this is not working at all. And this is one of the bits that is valuable about having both functional tests and unit tests. The unit test can check that individual pieces work, but the functional tests are really going to check whether everything is wired together correctly. And the thing that's missing here is that I know this table looks right, it has the right ID, it definitely has this new item text in if I want it to. So what's broken is somehow I'm not sending that request to the server, and that's because this input isn't yet in an official form. So I have to do form method equals post over here, action equals slash, and that changes this little input that's just hanging around into a real form that's going to cause the browser to send that post request. And I think now that I have the name in the input is correct, the form is an actual post form, then when the user types into it, they will actually send something to the server will receive it, put it into that variable, render it into the template, and I will have a to-do list website that can render at least one to-do list item, or will I? And so then the final little thing is, when you get an unexpected failure in your functional test, you might go, okay, I'm really confused about what's going on here. I've been writing a lot of code and tests, and I've lost track of what's actually happening in the application. Let's try it out manually. So I've got the run server running in the background. If I open Firefox here, somewhere. Mark, can you help me open Firefox? Firefox. No, right. Yep, local host 8000. Okay. So, how do I put it over there? Okay, how can I put it across? That's all right. We'll get there. Folks, next time you have to present a tutorial, make sure your laptop doesn't run out of batteries and that your laptop's charger doesn't cause weird interference with the VGA output that means that you can't actually use it. Okay. So if I put some element, I get this. Some sort of error saying forbidden CSRF error. So what's this all about? Does anyone know what a CSRF error or like injection vulnerability is? Or a CSRF, what's it called, verification is? Yes, sir? So yeah, whenever I look into this, I also kind of forget the very specific details of this. But this is a security feature of Django, and it's saying when you create forms on your website, you don't want somebody else to be able to create a form on their website that submits data to your website. And the reason this particular security vulnerability is, if I create a form on my website, like evilharry.com, that is posting to Harry, let's see, maybe I'm good Harry. Okay, so if I have evilattacker.com and it creates a form that submits to-do lists item to my website, they're going to get submitted from the user's browser with the user's cookies. And so without their knowledge, someone going on an attacker's website could click a button, and that's actually sending information with their authenticated credentials to a third-party website. So how do we stop that? We need to tell whether, when a post request comes from the internet, which we can't tell where it really came from, did it come from our site and code that we generated, or did it come from an evil attacker? And the way that we tell that is we put a secret token into every single form on our website that is uniquely known to us and that only we can generate and that attackers cannot fake. And it's secret because it's got some cryptography that marries the user's session with some hashing, blah, blah, blah. But one way or another, it's saying, okay, listen, your form doesn't have this magical token in, so I'm going to reject its input for security reasons. And now I can't get the tab back on this window. Oh, I think you just have to sit next to me for the whole thing now. Well, maybe I can look at it from the monitor over here. Okay. Right. Okay, so list templates home.html. So what I need to do into this magical template, I need to put a CSRF token, and the way Django gives that to you is our lovely curly bracket percent syntax CSRF underscore token, close curly brackets, close percent, save. And then I've got a chance of having some code that works. Jesus. All right. Did I, make this smaller somehow? Yeah, I did. Right, that's better. I'm having such a bad time. All right, come on, one of these ones. One of these ones is the one I want. How many? How did that get deactivated? And why? Why did I uninstall Selenium? It's a good question. Pew activate, what was it? Work on? TDD workshop, like this? Python. Oh God. This is a catalog of errors. Okay. In a minute, we're going to see a functional test that passes, I swear. Yes. Thank you. Finally. All right, fine. So we have now got all the working part, almost a clap, but not quite yet, sir, because we've still got an unexpected failure. So we have now got a form. It has the form tag. It uses method equals post. It has the right name. It is passing that stuff into the view, which knows the difference between post and get request. When it has a post request, it extracts the user input. It injects it into the template as a new variable. It is working, and my test is still not passing. And now that I've stopped being clever and I've got my assert in, I can see the reason 1: by peacock feathers was not found in by peacock feathers, and it's because in my functional test I say the user wants to know what order their to-do items is, and I haven't yet put an order into them. And the way I'm going to do that is I'm going to go list, templates, home.html, and remember we're saying for now our list only, our to-do list website only supports one item, so I'm just going to hard code 1: in there, and we're just going to accept it. If you're working like this, then you're going to have your hacks, and then we'll get it around to later supporting multiple items. But hard-coded 1: will get me to 1 peacock feathers, finish this test. Fantastic. And so the next stage will be to extend the test and say, can you add a second item? Then it will say no. Then we'll be forced to actually write a website that uses a database and saves the items forever. Good. So to recap on that, what you need to do is find chapter 4 of my book, copy and paste the code for the functional test, which is in efunctionaltest.py, which contains all this stuff about input box, send keys, blah, blah, blah. So that's chapter 4, the philosophy in refactoring. If you're in there, look for the string send_keys, and it will jump to the right listing. Copy and paste that in. Once you've got that, I want you to go and start a lists tests.py. A second unit test that checks post request work. We're going to do self.client.post, post some stuff, assert that it appears in the rendered response, and then finally, you're going to go and implement in your actual view function a different branch for handling post requests, where we fetch the user's input, put it into a variable called new item text, and we put that into our home template. Oop. I've got about 25 copies of Vim open on the second file. And it's going to need a form with a CSRF token, with an input, and a table with a TD, and that new item text variable. And that is all of the moving parts and working pieces that you need to actually process post requests on a server and generate them from Selenium. And at every stage, the functional tests are the ones that will really tell you, have you got anything missing? Did you forget the CSRF token? Did you forget the method on the form? Did you forget to put the form? Did you forget to put the name attributes on the input? All of these things are covered by the functional test, and the unit test will cover the actual code in views.py. So there's a lot of things I demonstrated there. If you're a little lost and you can't remember them all, the chapter that we're currently in is chapter 5, Saving User Input, I think is the title of that chapter in the online version. So before I hand over to you, are there any general questions about what's happened here? Yes? Describe the difference between functional tests and regression tests. I wouldn't know how to define a regression test. I know the word a regression in a test is when you have some functionality that used to work and that stops working. So that's a regression, like you've regressed. You've had some feature that used to work and it doesn't work anymore. And so any failure in any test can indicate that you weren't expecting, indicates some sort of regression. So I'm not quite sure how people use the term regression testing. Does that answer the question? Yes.
I would see the functional versus the regression would be if it was tied to like a behavior framework, like Gherkin or something like that.
Okay, I think that's a terminology issue, and you guys should take that offline and talk about it. My personal terminology is different. Yes.
So you began talking about TDD.
Yes.
Can you describe the difference between like test-driven development and test-driven design?
Test-driven development, test-driven design. That's a really good question. I don't know. I don't have an answer for that. This guy's supposed to be a plant and ask questions that make me look good, rather than questions that make me look bad. I mean, we can talk about how writing tests for puts you into a certain mindset to help design your code. But that's kind of more of an intermediate topic, which I do talk about in my book. I'm not sure if I've mentioned that I wrote a book about testing. But around 16, 17 chapters in, I start talking about how unit tests can actually drive out better design in your code. And it's one of the things that you're trying to get to. So good question. Read the book. It's available for free. You can also buy it online if you like from Amazon. I can give you a link to a little affiliate link where I make about $1, $2 in royalties off every book. So I really appreciate that. But my publisher appreciates it more, and they've been great. So do buy the book if you can afford it, or buy it for a friend. But read it for free. I don't mind that either. Yes, sir. Yes? Ah, yes. Good question. Good question. Yes, it's bad. Yes. So, yeah. Yes, there absolutely is. And that is the topic of the very next chapter in my book, which is available online and from all good bookshops. Yes. So you'll have seen in the functional test, where we go, functional test.py. Over here in the functional test, I've got this kind of magic time.sleep, which is saying, immediately after I hit enter, I'm just going to wait 1 second for the new page to load. And that's sort of crappy. What if your web server is really slow and takes 1.5 seconds to load? So basically, Selenium is kind of asynchronous. So when you do stuff, it kind of does them immediately and then gives you back control. And so it doesn't wait for the page to finish processing whatever it's doing. It does actually wait sometimes, just not consistently. So one of the difficulties of using Selenium is handling the fact that like stuff you do to your web page may take some time to actually reflect, and you need a way of saying, now, rather than assert this thing as true immediately, wait until it becomes true with a certain timeout. Like, so I'll say, look, I might wait up to 5 seconds for the server to display this message, but any longer and something is broken, so I want to fail. And in the next chapter, which is called Implicit and Explicit Waits, I talk about how you would do that with Selenium. Excellent question. All good bookshops. Yes? Yeah. Yeah. So good question. How do you decide when you're, so we had the example of like having a test and then jumping between the test and the code, and every single line, a little bit of code is going to be tested. I tend to find that for Python code, I'm going to be jumping between the unit tests and the unit tests and the actual editor very often. But in HTML, not so often, because you're adding some tags, you're changing a header, you're maybe changing some CSS, and all you're here doing is you're probably just changing kind of the way things look or what color they are. So these are all kind of implementation details rather than behavior. And so that's that rule about don't test constants and try to test behavior rather than implementation. So the cases where you're just changing some implementation stuff or changing some cosmetic stuff are the times where you're probably not going in those frequent runs of tests. But the times where you're actually changing some logic, or you're doing some refactoring, or you're actually writing new Python code are the times where you're doing minimal code changes. And you develop a feel for that as you grow. But in general, actually this is a good time to mention the bucket of water thing. And then I promise you can start programming again. Ken Beck, who's one of the originators of TDD and extreme programming, said that test-driven development or programming is a little bit like pulling a bucket of water from a well. So if you have a well and it's not very deep and you've got quite a small bucket, you chuck that bucket down there and you pull it up on the rope and you get it up and you're done and you're good. And that's like programming when it's easy. But supposing the well is quite a lot deeper and the bucket is quite a lot larger, you can throw it down, you start pulling, and then after a while you get tired and you get more and more tired, and the bucket gets about halfway up, and then you're so tired you let go and the bucket falls all the way back to the bottom and you've lost everything you've done. And so instead on a well, what you would typically have rather than just a rope is a rope that goes through a ratchet, and you pull on the ratchet, and when it's hard work and you want to stop, you can let go, and the ratchet saves your progress, right? It stops, and the bucket stays where it was, and then once you're less tired, you can start again. And so in a similar sort of way, having a set of tests which tell you whether things are right or wrong lets you have a sort of ratchet for your code, and it lets you know when you've accidentally broken things. You can just go, oh, hang on, I broke everything. Let's just cancel all of that and go back to where we were before. So having test coverage helps you know when you've got regression, and then having version control is the other one thing that you need to make sure that you can always go back to a clean state and go back to where you were when everything was working. So that's the TDD as a ratchet for your code. Yes, sir. Final question, and then there's programming, surely. Yeah, you can do all of that with Selenium. No. So Selenium will let you test different browsers, and that's really a topic that's more advanced in the book. I talk in the continuous integration chapter about setting up a server to do things. You can tell a server, you yourself will probably run just one browser or one or two, and then you can tell a server to run 25 different browsers with a million different versions. That is something you can do. I'd call it an advanced topic. Yes. All right. What time are we due to finish? Where's Tyler gone? Tyler? Okay, so we have 2 minutes. I'm sorry, you guys. Maybe no programming at this stage, but as you know, the whole book is available online, so you can do... Did you know there's 2 types of comedy in the world? There's comedy based on repetition, and there's comedy based on repetition. All right, so final questions then before I let you all go. Yes. Yeah, the topper. Anything else? Alrighty then. So my name is Harry. I am doing a book signing for somebody else's book, no, for my book. And that is tomorrow at 10 o'clock. If you fancy it, O'Reilly giving away, I think, 20-odd books for free. So as long as you get in there and you're early in the line, you'll get one. So do that, or buy it. That's nice too. Or buy it, or read it online. That's tomorrow at 10. And I'm around all conference, so feel free to just come up, interrupt me mid-conversation with other people. I really don't mind. I'm very, very happy to answer beginners' questions or anyone's questions, really. There's a question here, yes? Shh, everyone. Shh. Absolutely not. If you've only done this tutorial, you cannot jump straight to the intermediate. That assumes that you know quite a lot more about testing. Any more questions? Nope. Good. Well then, thank you very much. Thank you for bearing with me during the laptop problems. Thank you for coming. I'm flattered. And see you all soon.